What's going on, pre-calc students? Today we are moving forward with solving trig equations. Alright, so yesterday we did a little bit of work in class on if I gave you a picture of a unit circle and gave you solutions, or like gave you the rays that I was looking for. Sorry, I shouldn't say rays, the angles, okay? Well then you could write general equations to explain or to show those angles forever and ever and ever, right? Like pi over 4, 9 pi over 4, 17 pi over 4, etc. You could write equations for that. Today, if you notice, I'm going to actually give you a trig equation, and then you're going to have to come up with your own picture. Alright? So to solve these guys, first thing you have to do is you have to simplify the trig equation. Alright, that's number one. First thing, simplify the trig equation. 2, sketch unit circle and the solutions. Alright, now the solutions, please remember, are going to be angles. Alright, so you sketch your unit circle and then you need to sketch or place the solutions correctly based on your trig equation. Lastly, we have two options. 3a would be to write general equations, or general solutions, general solution equations. And so, for example, something like this, if it says to solve in general, well then we'd be done here after writing the general solutions. However, more times than not, and especially in today's video, we're going to have to make a list of possible solutions on interval 0 to 2 pi. Alright, so I'll explain a little bit more what that means as we move on. Alright, so if we look at this, solve the equation in general, cosine theta equals 1/2. Alright, this is simplified already. This is already simplified. I already have cosine theta by itself. And what's really great is if I remember that cosine always goes with x, well then when I sketch a unit circle, and it doesn't have to be pretty, but when I sketch a unit circle, well, I can place my solutions on this unit circle because I know where x is going to be 1/2. It's going to be 1/2 up here in quadrant 1. And if we remember x of 1/2, that means this is pi over 3. But it's also going to be down here in quadrant 4. And this is 5 pi over 3. Alright, so if you remember, this is exactly what I gave you yesterday. I gave you this picture, and now, or then I asked you to come up with what we're doing now, or next. Okay? So, we need our general equations, or general solutions, excuse me. Theta is going to be equal to, now, is this one going to have two equations or one equation? Is there a single rule that can get me from this ray, this angle, to the next solution, and then back? And I'm going to go ahead and say no, because it would take 4 pi over 3 to get to this solution, and then if I added another 4 pi over 3, I would go way past this one, okay? So there is not a single pattern, which means we need to write two equations. We need to write one equation for this ray, so pi over 3 plus or minus 2 pi n, because we know it's just going to keep going and going and going and going around and around. And then the same thing over here. 5 pi over 3 plus or minus 2 pi n. And guys, for this problem, this is the general solution. That is what we asked for, so we are done. Now, when we move on to our next example here, this next example, it now asks or says the word interval, And even further, it says what the interval is. It has to be between 0 and 2 pi. Okay? So, while I would say that this is simplified already, I need to remember that tangent is always y over x. So I'm going to need to work with this a little bit. As of right now, I don't know where exactly I'm at. So this is a situation where we might need to use our over 2 trick, and I might need to rewrite this as square root 3 over 2 all over 1/2. Okay? And if we do that, well, now I can start to see where I might be on a unit circle. So I'm going to go ahead, I'm going to sketch a unit circle. And I need to start figuring out where these are going to be. Okay, now remember, if it's y over x, then my first one is just an x value of 1/2 and a y value of root 3 over 2. So that's, again, pi over 3, which is great. Where else can tangent be positive, right? Well, I could also do negative root 3 over 2 divided by negative 1/2. So that would be over here at negative 1/2 negative root 3 over 2. Which is 4 pi over 3. Okay? So now that I have my two solutions on one rotation, I can go ahead, and in this case, I'll ask one equation or two equations? I hope you said one. There is a single pattern or a single rule that can get me from pi over 3 to 4 pi over 3 and then around and back and back. Please remember, unit circle stuff. If this is 0, well, this is pi, but we're going to write it as 3 pi over 3 instead of just pi. And now we know that every time we go around, we're just adding half of a circle, 3 pi over 3, plus another 3 pi over 3, etc., etc., etc. So, in this case, I could say my first angle, pi over 3, plus or minus, and in this case, I'm going to go pi n. All right? Pi n. Now, if it asked for general solution, we're done. But it didn't. All right, it wants a list of the intervals, or it wants a list of the solutions on this interval, excuse me. So, I need to get it. And I'm here to tell you, and I think I mentioned it yesterday, you could, for right now, you just look at your unit circle. I know that these are going to be the two values. I'm telling you that as these problems get harder, it's going to be way, way, way easier to get the correct solution or correct list of solutions by using your general solution. All right? And so what I mean by that is, well, I know that my first angle is pi over 3. But then I know I have to add or subtract pi n. So really, this is just my step. One thing I would think about is that pi can be rewritten as 3 pi over 3, because now I know that I can just add or subtract 3 pi over 3 over and over and over until I get outside of the interval I'm looking for. Well, hopefully you agree with me. If I subtract 3 pi over 3, I'm already below 0, so I don't want to subtract. If I add 3 pi over 3, I get 4 pi over 3. And if I add another 3 pi over 3, I get 7 pi over 3. Well, be really careful, because we know that if over here, halfway around a circle is 3 pi over 3, well, then this is 6 pi over 3. And that should tell us that when I get my next one, right, if I do 7 pi over 3, well, I cannot use that. That's too big. It's outside of the interval. So my correct interval, I keep saying it, my correct list of solutions on the interval is right here in the brackets. Okay? So, we move on. We have some tougher problems, I'd say now. And by tougher, I just mean we have to do some simplifying. So if I take a look at this one, I can use some algebra. I can say that 2 sine theta is going to equal negative root 3. Or I can even say sine theta is equal to negative root 3 over 2. And that's great, because now I could draw a unit circle. Alright, so I sketch a unit circle, and I need to think about Ooh, sine is y. So I want everywhere in my unit circle where y is negative root 3 over 2. Well, I know that occurs down here in quadrant 3. And that's 4 pi over 3. It also occurs down here in quadrant 4 at 5 pi over 3. And now that you have those solutions, you can go ahead and you can create your general solution. How many equations? 2 equations. We cannot get to this. Like, we can't add 4 pi over 3, or start at, I guess we'd start at 4 pi over 3, excuse me. And we would just add pi over 3. If we kept adding pi over 3's, we'd have another solution here, and here, and here. We don't. So there is not a single rule to get me from my first solution to my second, and then back around to the first. Which means I need 2 equations. 4 pi over 3 plus or minus 2 pi n. And 5 pi over 3 plus or minus 2 pi n. Sorry, that looks a little sloppy. Once again, this is my general solution. But I don't want the general solution. I want the solutions between 0 and 2 pi. So now I need to make a list. I start with my first, and then I know if I had 2 pi, well, I already know if I'm adding a full rotation, that's going to be way outside, so I don't need to worry about another one here. But I move on to my next equation, and I see I have another solution at 5 pi over 3. Once again, if I add 2 pi, I'm going way, way past a full rotation. Or I guess I'm going way past 2 pi. It would be a better way of saying that, excuse me. And so now I know that that is my final list. All right? And again, when we just have theta, not 2 theta or 3 theta or theta over 2, you can just use your picture. Like this should make sense why these are the only 2, because those are the only 2 on our unit circle. All right? Now these last 2 require you to do some square rooting, and so I want to talk about that. So we would solve this normally. Now I would need to square root both sides, and this is where I need to apologize, I guess. Every time we've done the Pythagorean theorem, I've always just said that the square root is the positive version, right? Well, we need to remember, guys, that when you square root a value, what's really happening? You're really getting plus or minus. Okay, I think the reason that I always forget about it with Pythagorean theorem is that it's a triangle, and usually triangles, like side lengths, don't have like positive or negative, right? They should always be positive. So I think that's kind of why I skipped out on it, but we need to bring it back right now. And so we would continue here. I can go a little further because 1 is a perfect square. So I'm going to say I have 1 over root 2. Now please, please, please understand. Sine is y. I do not know on a unit circle where 1 over root 2 is. But if I rationalize this, then it becomes a really, really nice ratio. It becomes something nice. So again, I don't require you to rationalize, but I want you to be able to, because if we rationalize this, we get root 2 over 2. And now I know that that is my y value. And now I can sketch my unit circle. Okay. Ooh, not the best, whatever. Let's take a look at this. Sine, or y, has to be plus or minus root 2 over 2. Well, the positives are up here at pi over 4 and 3 pi over 4. And then the negatives are down here in the lower quadrants at 5 pi over 4 and 7 pi over 4. So now I know that this one is actually going to have 4 solutions. One thing just to be on the lookout for, like you might wonder if it's super important, the plus minus, and I would say it is, because if we only said the positives, well then we'd only have the top two solutions. We wouldn't have the bottom two. So it's really important for you to understand the positive negative aspect of this. Okay? But this is great, actually, because how many equations do we need here, guys? 2 pi over 4, 2 pi over 4. Oh, we only need one equation. I just need pi over 4 plus or minus pi over 2n. How did I get pi over 2? Well, you can think about it as you're adding a quarter of a circle, and we know that a quarter is always pi over 2, pi over 2, pi over 2, pi over 2. The other thing is if this is 2 pi over 4, I should have changed colors there, my bad, let me do that again. If this is 2 pi over 4, right? Well, then that's the same as pi over 2. Okay? So now we have our general, but we don't want the general. We want a list. So I need to make a list. I start with my original, so pi over 4. Now I'm going to add pi over 2. But actually, guys, I think it's going to be easier to think of pi over 2 as the 2 pi over 4 that we were talking about earlier. Because I'm going to just take pi over 4, and I'm going to continue to add 2 pi over 4 until I cannot go any further. So pi over 4 plus 2 pi over 4 is 3 pi over 4. Plus another 2 pi over 4, 5 pi over 4. Plus another 2 pi over 4, 7 pi over 4. Plus another 9 pi over 4. Oh, wait a minute. Ooh. If I'm talking fourths here and this is 2 pi, isn't that the same thing as 8 pi over 4? Yeah, so we can't count this one because it's outside. I couldn't even see it anyway. It's outside of 8 pi over 4. It's outside of 2 pi. So I need to get rid of it and close off my bracket. Okay, almost done. Last problem. I hope this stuff is making a little bit of sense here. 3 tangent squared theta equals 1. Well, divide. So we got 1/3 and then square root. So let's see here. We have tangent theta equals plus or minus 1/3. But please remember that when you take the square root of a fraction, you can just take the square root of each piece separately. So tan theta equals plus or minus 1 over root 3. Okay, this is good. I don't even think I want to rationalize this, guys. Because tangent, if we remember, is y over x. And I can kind of use that, what? I can use my trick. I can say that this is really 1/2 over root 3 over 2. So now I can see my y's and my x's. When I go to make my unit circle, we have to be really careful that we get all the solutions. Now you need to remember, it's tangent, positive, negative. Alright? So for the positive ones, let's think about positive first. It has to be plus plus, minus minus. So that means I would have to go a positive root 3 over 2 and a positive 1/2. So right here at pi over 6. Or it could be negative negative. So it could be a negative root 3 over 2, negative 1/2. So 7 pi over 6. Well, just remember, it's also the negative ratio. So that means I could have a negative x and a positive y. So I'd be in quadrant 2. So negative root 3 over 2, positive half. And we would say that that's 5 pi over 6. And lastly, we could also have a positive x and a negative y. So positive root 3 over 2, negative 1/2, and that gets me my fourth solution. And this would be 11 pi over 6. Alright, so now I need to ask how many equations in our general solution. I do not have a pattern that gets me from pi over 6 to 5 pi over 6, and then would continue to get me to my next solution, right? Yeah, 4 pi over 6. Oh, if I added another 4 pi over 6, I'd be at 9 pi over 6, but I don't have a solution there, okay? So it doesn't work. We need two equations. We need to say pi over 6 plus or minus, and well, I can add a full pi, 1/2 rotation. All right, that would get me to 7 pi over 6, and then back and back and back and back. But I also need to take care of my other solutions, this other set. So 5 pi over 6 plus or minus pi n. And again, this is what we would call the general, but that's not what we want. We want a list. All right, so we would take our pi over 6. That's our start. Well, think about this. I know that I'm going to go, how else could I write pi? If I'm talking with a denominator of 6, oh, I could make this 6 over 6, right? I can make both of them 6 over 6. So if I added pi over 6 and 6 pi over 6, I would get 7 pi over 6. Oh, I'm going to write this 5 pi over 6 first from the other equation, just so I have them in order. All right, so I went pi over 6, and then 5 pi over 6. And now I'm going to say, well, my next solution from the first equation would be 7 pi over 6, and that's perfectly okay. 5 pi over 6 plus 6 pi over 6 is 11 pi over 6. I could try to keep going here, so I had 7 pi over 6 plus 6 pi over 6. That's 13 pi over 6. Oh, 13 over 6 is above 2, all right? 13 pi over 6 is more than 2 pi, so I can't list it because I can only be between 0 and 2 pi. So I would close my bracket, and I would say I am done. Okay? So, again, from this chapter, I'm hoping that you're feeling more comfortable with a couple of things. One, being able to draw the unit circle and draw your solutions on there. Being able to understand how to write general solutions. And then really understanding how to use the general solution to help you get your list. I am very, very aware on all of these interval problems, you could have just used the picture. I get it, right? They're the same. What I'm trying to let you know right now is starting tomorrow, I'm not always going to just give you something like sine theta. I might give you sine 2 theta. And it's going to be a little bit different. So being able to use the general solutions instead of the picture to make your list is going to be super, super important. All right? I hope you're doing okay with this stuff. I hope that you're starting to grasp it, and we will practice in class. Have a good one. Peace.